The title of tonight's talk is California Drought, Are We In or Out? Often called the prophet of California climate, please help me welcome Dr. Bill Patzert.
Okay, so the topic this evening is drought, all right? And that's a big topic. There are a lot of aspects. Everybody thinks they know everything about it, but maybe we'll learn something a little new this evening. So the first question is, what is a drought? Now, for some of you, a drought is like the last time you got an A, all right? Or the last time you got a pay raise, all right? Or the last time you had a date. But I'm Dr. Bill, not Dr. Phil, all right? I'm going to talk about a water drought. Now, one of the things I'm going to tell you this evening about this drought, there is a strong connection with what happens out in the Pacific to what happens to rainfall and snowpack and just about everything else in California. So the simple message this evening is when the Pacific speaks, we better all listen. Then at the end, we could talk a little bit about short and long-term solutions for droughts. Now, the history of California is written in droughts, and so we're always talking about solutions. But in the last couple of decades, this has become a little more serious than it was in the past. Okay, now the first question is, how can you tell you're in a drought? Okay, when the San Pedro water cops show up here this summer and you haven't done your 25%, you'll know you're in a drought. Okay, let's look at a little data here. Now, this is 1945 to the present. All right, so that's about 70 years of data. This is downtown Los Angeles rainfall in inches here. And so you can see the average is about 15 inches downtown. Here in San Pedro, it's between 10 and 12 inches. The closer you get to the ocean, the less rainfall you get. Now, the interesting thing about this is, are there more years above average or below average? Just look at it real quick. Below. Okay, good. What a good group of students, yeah? Turns out that 7 out of 10 years are below average for the last 70 years. Now, that's kind of interesting, all right? So, generally, people are always asking me, what's the rainfall going to be next winter? So, what are the odds when somebody asks you that question? Below average. You wish you had those odds when you went to Vegas, all right? 7 out of 10 are going to be below normal, all right? So, in some ways, drought in Southern California is really normal. What's abnormal is if we get average or above average rainfall. So in some ways, we live in a drought all the time. Now, what do droughts look like? This is the same data. And what I have done here is highlight, I love PowerPoint, I really get carried away sometimes. Notice from 1945 to about 1977, there were a lot of below average rainfall years, all right? And so instead of 15 inches, for those years, the average was only 13. And some of you will remember the drought that culminated in 1977. That was the last really serious drought. It's often compared to where we are this year. And then that was followed by a couple of decades of pretty wet years. So that was about 20 years from the late 1970s, which culminated in the big El Nino of 1998, where rainfall was 17 inches compared to 13 inches. And this is where we are in the present drought, which I will show you really began in about the year 2000. So this drought didn't start 4 years ago. This drought started 16 years ago. Now here's a little, I like history. I love history, all right? Now, in between these wet years, there was a mini drought. Some people will remember that, 1987 to 1992. Well, if you go back in history to 1878, these were the 5 driest consecutive years in modern California history. And so that was 5 years where the average rainfall was less than 10 inches. So that was pretty serious. It was during that period when people started painting their lawns, all right? Now, anybody know what those pink lines are? What happened during those periods? Look at it real close. This is for the really sharp students. That's when Jerry Brown was in office. All right? Now, I love Jerry Brown. I voted for Jerry Brown 4 times. All right? What a great governor. All right? Now, the interesting thing about Jerry Brown, that he was elected for the first time in a very serious drought, which culminated in 1977. And then in his second term, we had some of the wettest years in California history. 1978, 79, and 80, those were 3 of the wettest years we've ever seen in California. The average rainfall was 27 inches for 3 years. Okay, now, of course, I voted for Jerry Brown the 3rd time. Now, what happened in his 3rd office? Again, he was elected into a drought. This drought, all right? And of course, he's a little grouchy these days about this drought, and everybody pretty contentious. But wouldn't that be ironic? Is that in his second term, all right? His 4th term, is that we get bailed out of this drought one more time. And I believe in that. I'm a scientist, but I believe in luck. So I'm pulling for Jerry Brown. All right. Now, the point of the last slide is that a drought is not zero. It's not even half of normal, all right? A drought is about 80% of average rain over a few decades or less. That's all it is. It's a few 15% below average for a couple of decades, all right? And the last 4 years is a mini drought, all right? But the real drought, they usually last decades. Now, this is the United States Drought Monitor. It comes out every week. This is the new one for this week. And everything that's dark here, or yellow, is in drought. Now, the thing you notice here, what's the worst place in the United States for drought? California, and it's been this way for a while. That's a lot of really exceptional drought. But a lot of the West, Utah, Arizona, New Mexico, large parts of Texas, there's even serious drought in Washington and Oregon, which are normally pretty wet. And so the thing about droughts is they're large, all right? It's not just a drought in San Pedro or Southern California. In some ways, when these droughts show up, it's half the United States. Half the United States. These droughts are large. All right, and this is kind of cool. I stole this from a website, but you can see it cycles here for about 4 or 5 years. And the interesting thing is, all right, in 2011, it starts slowly, starts to build up in 2012, 2013, 2015, okay? So what's the point? Droughts are slow. You creep into a drought very slowly. It doesn't happen overnight. It gets worse and worse and worse. All right? Now here's another one. This is an interesting one. This tells you 0 when there's no drought and 100%. So when it's high here, the drought gets more and more serious. So remember I told you the drought started in 2000. So notice that from 2001 to about 2006, we had 5 pretty serious drought years. And then we had 2 wet years in between. And then we had 3 really serious dry years. And then remember 2010 was a pretty wet year. We had 2 wet years. And now we've been in 4 really dry years. So each time it got worse. It was building and building and building. And so if you count it up here, is that you got 4 wet years and 12 dry years. So that's what a drought really looks like. So droughts wax and they wane. So sometimes you get one wet winter or two wet winters and you think you're out of the drought. But it's like the Godfather. You're not out yet. They pull you back. All right? So this is what a drought looks like. Now this is another one. This is, I love data. I hope, I'm not confusing everybody with all this data. I tried to make it simple. But this is California winter temperature going back to the beginning of the 20th century. So there's 110 years of data of temperature. It goes up and down. There's a lot of big spikes. 1934, that was a pretty warm year. You can see it. What was 1934? Anybody remember? That was the end of the Dust Bowl. Big drought. All right? And here's, the average temperature is here. But the thing you notice about these temperatures, what's happening over the century? There's a trend. What's the trend? It's getting warmer. It's getting warmer over the last 100 years. All right? That's the global warming trend. It's about 1.6, 1.8 degree Fahrenheit. And that's what the global average temperature is for warming over the last 120 years. And so you're living in a warmer world. The state of California is getting warmer. All right? Now, also notice the last 2 years. Look at this, the spike in temperature here. 1934 was the previous record, but the last 2 years, we just smashed the record. The last 2 years have been almost 2 degrees Fahrenheit above the previous record. Right? So this drought, one of the reasons it's gotten so serious is because it's been so warm. Remember how the last 2 winters have been unusually warm. Right? The ocean's been unusually warm. So these were the Dust Bowl years here. That was the previous record. That was from about 1928 to 1935. Those were very dry years. So right now, all of a sudden, the thing you could say about this drought, we said it's large, it waxes and wanes, right? But this drought has been a scorcher. It's really been warm, unusually warm. And of course, that has consequences. When it's 2 degrees warmer, now, it's already 1.8 degrees warmer in the last century because of global warming. And so the snowpack always comes later and it disappears earlier. This is a well-known measured fact. All right, so the snowpack in the Sierras, which we depend on for our drinking water in the summer and into the fall, it's been shrinking steadily for the last 100 years. But the last 2 winters were so unusually warm. Look what happened. So this is the normal snowpack, right? And so you see it here, all right? Remember I told you the 87 to 92 drought? The 2 wet decades in front of it and behind it? All right, and this is our drought. Notice, you see it in the snowpack, remember? I told you it was dry, it was wet, it was dry, it was wet, and it's dry again. That's the same waxing and waning I got from the drought monitor, all right? And so you see the waxing and waning. But the number here, this year in the Sierras, for the snowpack, is 5%. So what does that mean? That means there's no snow. There is no snow. Literally no snow in the Sierras, all the way from Oregon down into Southern California. Now, normally that snowpack supplies 30% of our drinking water during the summer and fall. So that's another reason this drought is so serious. Because it's a reservoir in the mountains that we can use later. But it disappeared. So we've never seen anything like this in previous history. So it's 5% of normal. For all practical purposes, it's 0 right now. And so we had more snowpack from this little puny storm overnight than we had left over from the previous winter. That's pretty serious. So it's hot, it's dry, all right? And the end result is puny to no snowpack. So that's another thing about this drought. Now, I can take hot and I can take dry, and I make an index out of it, which is a precipitation in what I call an evapotranspiration index. That means you take the rainfall and the heat and you combine them, all right? And so this goes back to 1900. We started wet. Here's the Dust Bowl drought, all right? Here's the wet years after, this is Jerry Brown's second term, all right? No, I'm sorry, over here. Yeah, right, over here. All right. No, this was the El Nino of 1941, all right? Those of you that can remember that. Those were extremely wet years, by the way. Those were really interesting years. Had a big impact on World War II, but that's a different story, all right? But here's the mid-40s I talked about earlier. Into the 70s, you notice how it waxes and it wanes? But the thing you notice about this, in the long term here, what's really happening to droughts, which are the red parts of the curve? They're getting worse, all right? So droughts are getting worse. All right, so there's the Dust Bowl drought, all right? Here's the Jerry Brown first and second term drought, all right? There's the 87 to 93 drought. And there's the present drought, which we will find out shortly when that will end. But the interesting thing here is that droughts are getting worse in California. And that makes sense, because the primary reason is because it's warmer. All right? So droughts are intensifying. All right? So they wax and they wane, they're large. All right? And so we have pictures like this. It's a very photogenic drought. This is Lake Oroville. This is the largest water reservoir in California. It's in Northern California. All right? And you can see what happened here is that Lake Oroville, all right, is at 28% of capacity. I think it's even lower now. So the reservoirs are very, very low. And the snowpack, what happened to it? It's gone. So the two primary reservoirs, which are landlocked man-made reservoirs and our reservoirs in the mountains. And so that's why we're in serious shape and why Jerry Brown wants everybody to cut back at least 25%, which is pretty modest considering the situation. Now, I talked about this the other day in the LA Times. Because it's so dry in the mountains for the last few years, 4 years, the water tables have seriously dropped. And so the forestry department, there's 14 to 20 million, it says 12, but it's 14 to 20 million dead trees in the Sierra Nevadas, as well as over the rest of the West, because the water tables are so low. You know how that goes. The trees don't get water, they stop producing sap, the bark beetles move in and kill the trees. So that's pretty serious. So we're having a mass mortality of the conifer and pine forests all over the West. I'm full of good news, aren't I? So the forests are bone dry. So, you know, definitely everybody has to be careful out there. This could be a horrendous fire season. And it's not just the trees, it's all the ecosystems in the mountains, all the other plants as well as animals. So where I live, for instance, is right next to the National Forest. And I've never seen so much wildlife coming up to my front door as I've seen in the last 2 winters. And in the summers, it gets serious. So I live where the bears go. So I've actually seen bears in my yard. All right? So droughts are dangerous. Now, one of the things that sustains us here in California is that we have deep aquifers. When the great ice sheets migrated north and left huge deposits of gravel, sand, silt, all right, deep in the earth, and they filled up with water. And we've been drilling those for 100 years in the San Joaquin Valley, or a good example is in the Coachella Valley, where Palm Springs is, those 121 golf courses. that take 300 millions of gallons of water per golf course per year, all right? That water doesn't come from the Colorado, it doesn't come from the mountains, and it doesn't come from the rivers. It comes from these ancient aquifers. Now, nobody really knows how deep those things are, those aquifers. And so there is a myth here in California, especially among the farm community, that the aquifers are infinite. But we know nothing is infinite except in math class, right? So sooner or later, what's going to happen? Right now, they're drilling down to 1,500, 2,000 feet. One of these days, it's like when you go to In-N-Out and you get to the bottom of your chocolate shake, and all of a sudden you hear, all right? Then what happens when that happens? All right? So this is pretty serious. So this is what I call a recipe for disaster. The reservoirs are low, snowpack is not there. The groundwater, by the way, there are big groundwater supplies, shallow ones, especially in this part of Los Angeles County, Long Beach, that really have sustained us during this drought so far. But some of those are dangerously low too. And the aquifer reserves. And then, of course, the bad news just came on the Colorado, is that we import 30% of our water from the Colorado. But the Colorado has never been this low in recorded history. Lake Mead is its lowest level since they began to fill it. Okay, so there you go. So that's not a lot of good news, right? But it shows you a little bit the extent of the drought and how we got into it. Now, to even make things worse, here's a tree ring record that goes back 12 or 1,300 years. And my tree ring buddies, you know, they drill a hole in the tree and they count the rings and they can tell how wet or dry it was or how hot or cold it is from the tree rings. This is a record that goes back to 800, all right? And notice that this is average, all right, here. And so red tells you when you're in a large-scale serious drought. Blue tells you when it's wetter than normal. So it's kind of interesting, all right, is that notice these periods here in the 12th and the 13th century. Now, remember the Anastasi? Everybody remember them? The Mesa Verde living in the cliffs. All of a sudden they split. That was a period of a 100-year drought on the Colorado. All right? And so they essentially, it was a big civilization. They ran out of water. And of course, this is if you've read history at all, I love history, is that the collapse of many great civilizations have to do with tremendous growth in population during a period when you had plentiful water supplies, and all of a sudden you get hit by something called a megadrought. Right? During that same period, lots of civilizations disappeared in Mesoamerica, Mexico, Central America, Northern South America. This was a very large-scale, serious drought. And so the good news is that we're not in a megadrought yet. So that's the good news, bad news. Okay? But megadroughts do happen. Megadroughts do happen. And so, you know, there's a message for all you students that are going to school. There's a reason to study history and to study science, all right? Because, yeah, all those petroglyphs out in the desert, all right, what they really say is be careful of your water. Now, did anybody see this drought coming? Can this be predictable? Now, one of the things that I really hate, everybody hates this. Remember when your mother used to say, I told you so? It's like the words that nobody wants to hear. I told you so. Right? But here's the Pasadena Star-News. Anybody recognize this handsome old guy? All right? So, what a stud. Yeah. So he says, water shift spells drought, right? Says, JPL oceanographer says the Pacific. Now, can anybody read the date on that? Yeah, so see, the young people can actually see. All right, that was September 2002, right? So the only thing I want to say about that is, so at some level, we do understand these things well enough to predict them. Now the key is, can I predict when we're going to be out of it, right? Who cares about predicting when we're going to be in it, all right? So at some level, droughts are predictable, all right? But the real question is, why is the drought, right? And the answer is, it's the PDO. Anybody know what the PDO is? There you go, yeah. At least I've done some good in the world, yeah. One person remembered. Pacific Decadal Oscillation, all right? Now, what is the PDO? Now, some really smart buddies of mine at the University of Washington, actually they were marine biologists, of all things. They were studying the appearance and disappearance of anchovy and sardines and salmon along the west coast of the United States. And so they looked at 100 years of sea surface temperature data. So this is the Pacific. Got it? All right, North, South America, Asia over here. So they looked at 100 years of data, and they came up with these interesting patterns. They did a fancy statistical analysis. What they found was one pattern, looks like a wedge. Red means warm, warm water. A wedge of warm water coming out of the Americas into the tropics. And this is surrounded by, it looks like a cool horseshoe of water. Now, the flip side of that is that you get a cool wedge. See the warm wedge? Cool wedge, surrounded by a horseshoe of warm water. So if you use your imagination, this is really the same pattern. Can you see that? Except I just changed the colors. So one is a negative or a cool phase, and the other one is a positive. And so this is the pattern they came up with. Now, the interesting thing about this, so much of the Earth is covered by the tropics. When you get this positive phase, it's so warm, it actually warms the entire Earth. Let me say that again. Because the Pacific is 30% of the surface of the globe. So when you get this warm pattern, the surface of the Earth actually heats up. Whereas when you get this cool pattern, the surface cools off. And so that's why you can get decades where it's warmer or decades where it's cooler. All right. Now, what does this look like in time? This is 1900 again. This is the 20th century. And you notice that you get a couple of decades here from the mid-40s to the mid-70s. Remember the mid-40s to the mid-70s? The drought? All right? Where it looks like this. And then you get the 80s and the 90s where it looks like this. All right? And then the present 15 years where it looks like that. So what happens is the Pacific, sometimes it gets in a cool phase or a negative phase where we are right now. And that's the same thing that happened in the mid-40s to the mid-70s. And then in the 80s and the 90s, we're in a warm phase. So for decades, it can be in this large-scale pattern. It's pretty cool, huh? Now, I take the PDO, this tells you what phase of the PDO, and I just chopped up part of it, and I overlaid it with the rainfall in Los Angeles. This is downtown LA. So that's the PDO phase. This means the warmer. This means the cooler. Warmer, cooler. This is the mini drought of 87 to 92. This is recently, the last couple of decades. You notice how it waxes and wanes? It's not a perfect predictor, but the PDO is almost a perfect predictor of rainfall in Southern California. So there's got to be some kind of a relationship there. Right? So now you know my secret about how I do my long-range predictions. Right? So I'm out of business now. Anybody can do it. So when you're in a positive phase of the PDO, what kind of rainfall do you get in LA? Warm is red. Higher rainfall. All right? When you're in a negative PDO, you're in a what? Drought, there you go. Usually the best students are in the front, but I got some in the back over here. All right? So in a positive or a warm PDO, LA tends to be wet. All right? In a negative PDO, it tends to be a drought. And that's how I made that prediction and got my picture on the front page of the paper. All right? Now the question is why? Why is that? Well, when you get these large patterns of temperature in the Pacific, they have a powerful influence on the jet stream pattern. That's the thing that Dallas and Fritz show every night. You know, the jet streams coming out of the Pacific. It's either going into Alaska or yesterday it actually came right down into California. All right? But you tend to get this ridge, high pressure ridge, what they call the ridiculously resilient ridge, all right? That forms in the Northeast Pacific, drives the jet stream north, keeps us warm and dry in the west. Remember the large-scale drought pattern in the west. And the flip side of it is, then it comes straight out of Canada as the Polar Express. And so the Midwest and the Northeast gets battered, much like they have for the last 3 or 4 winters. So extremely cold, a lot of blizzards on the East Coast, Northwest, and we remain warm and dry. This is a pattern that we have seen for centuries. Right? And essentially the warm pattern or the cool pattern in the Pacific is the thing that drives this jet stream pattern, which delivers weather and rainfall either to the East Coast or the West Coast. And so all the warmth in the West and all the dryness in the West was made up by extreme blizzards and fierce frigid weather on the East Coast. So when you did the average between the East Coast and the West Coast, you came out with 0, which was much consolation. You know? But that's a pretty interesting pattern. So that's this negative pattern here. Right? The negative PDO, which essentially we have been in since about 2000. And that's the kind of pattern it gives you. And that's pretty cool, huh? Now, if you want to see the proof of the PDO, you can look at longer and larger things. And my favorite thing to look at is Lake Mead. Everybody been to Lake Mead? Been to Hoover Dam? Okay, all you young people, you got to go. Before you die, you got to go to Lake Mead and Hoover Dam. It's one of the great things to visit in the American West. Really, it's unbelievable. All right. Lake Mead has been dropping for 14 years straight, all right, at its lowest level in history. Right? You notice the ring around the lake? Now that ring tells you what? It's a mineral deposit. So when it was up here, the lake was full. All right, this is where it is right now. It's 141 feet. At its highest is when we had very wet decades, 1983 and 1998, which were big El Niños, if you'll remember. That's when the lake was full. Actually, it was so full it almost overflowed the dam. Those were good years. And this is where we are today. So this was the positive PDO, put you with Lake Mead full, and the negative PDO empties out the lake. So that means the whole Colorado watershed, all the way from Montana, Colorado, Wyoming, Nevada, has been in a drought, essentially for almost 15 years. That's pretty amazing, huh? Okay, so now comes the punchline. By the way, it's projected, all right, it's at 38% of capacity right now. Projected to go down almost 150 feet by the end of summer. All right, so the Colorado turned out to be a disappointment as well. All right. Now here's the question. Now at this point, everybody should be able to answer the question. When does the drought end? Who said that? Excellent. All right. All right. When the PDO shifts. All right? So the answer is eventually. But the reason will be when the PDO shifts, So what are we all sitting here waiting for? We're waiting for a shift in the PDO, all right? All right, so, you know, maybe the rain dances will help, but I don't think so, all right? So, in a simple way, this is what it is. So in 2000, we went from a positive PDO to a negative PDO. And we more or less stayed there. All right, so the question is, in 2015 or sometime in the future, what we want is this negative PDO to switch back to a positive PDO. Now I'm going to give you a little good news here, but first I'm going to show you something really cool. At least I think it's cool. Now anybody recognize this curve? This is the one that you either love it or you hate it, all right? It's mistakenly called the global warming curve. All right? It's the global temperature curve. So it's the average temperature of the atmosphere, the land, and the oceans. All right? And you'll notice everybody says this is the curve they use to prove that there's global warming. It's actually the wrong curve, but anyhow. Notice that there is a nice slope. And we know that the planet is getting warmer. And it's 0.12 degrees Fahrenheit per year. That's the average increase per year. So it's pretty small. But if you do 100 years, it's 1.2 degrees Fahrenheit. So that makes sense. That's what I said earlier. It's about a degree and a half. But there's details in this. Notice that from 1945 to 1977, the Earth was actually cooling, or the global temperature was actually cooling. Now what happened from 45 to 77? Drought. And what phase of the PDO were we in? If you're in a drought, you're in the negative phase, right? The cool phase, right? Then notice we switched to the positive phase of the PDO, and all of a sudden, we had a dramatic rise in the 80s and the 90s of global temperature. Pretty cool, huh? Then we were in the positive phase, right? And those were wet years in the American West. And then recently, for those of you that follow it, for the last 15 years, global temperature really hasn't changed very much. It's been called the hiatus, which is pretty cool, huh? All right, and by the way, during the first Earth Day, I was actually there during the first Earth Day. We were talking about global cooling, not global warming, right? And sex, drugs, and rock and roll, too. It was the 70s. It was good. You missed it, yeah? Trust me, it's not the same now. All right? Excellent. Just excellent, yeah. Okay, now, so let's summarize here. So, during a positive PDO, the Earth warms. During the negative, it cools or it goes into a hiatus. And then it warms and it goes into a hiatus. So, the PDO, this large pattern in the Pacific, actually modulates global temperature or global warming. That's pretty cool, isn't it? So it's bigger than the drought. Now, during that same period, when Earth is warming, California is wet. When it's cooling, it's dry. You see the switches here, all right? And so the PDO is a California drought maker and drought buster. That's pretty cool, huh? Now, that's why I get paid the big bucks. I actually connected those two things together, all right? And wrote a paper about it. Pretty neat, huh? But what you really want to know is when it's going to switch again, right? All right, so here's the big question. The positive PDO, remember when it's warm and we're wet, are they back? This is what the positive PDO looks like. Now, I collect data from space at JPL from a satellite that measures the height of the sea surface, how much heat is in the surface of the ocean. This was my latest image. I actually got this morning from the satellite, processed the data. Notice, see the warm wedge? Pretty warm. See the tendency in the North and the South Pacific for a horseshoe? Now that looks disturbingly like this. Now, I'm speculating by midsummer I'll be able to come back and tell you that we have actually done a switch in the PDO, and what would that mean for the drought? No, it's never going to be over. You're always in a drought. Come on. Yeah? But you might have a wet winter. All right? And so this is what I call, you know, this looks like a big El Nino, right? And I always call El Nino the great wet hope, all right? We're always hoping for an El Nino. But of course, most El Ninos tend to disappoint. Like most husbands, you know. We're the same thing. Yeah? All right, so the question is here now, are we in for the big switch from a negative PDO to a positive PDO? And so will there be the great wet hope or the El Nino wet winter of 2015, 2016? But that means not until January or February, okay? So guaranteed we still have another 7 or 8 months. And this one's not guaranteed. But I'm giving you a little hope, all right? Now I'm going to switch a little bit here. I talked about Mother Nature and how the Pacific controls our weather and our droughts and what we might be in store for and what we've been through and why we've been through it. But there's another aspect of the story. That's Mother Nature. The other aspect is human nature. All right? Can we cause droughts? What's the answer? Yeah, of course the answer is yes. Yeah? Otherwise I'd quit right now. Now, here's a picture I took with my brownie from Mount Wilson in 1902, looking down on Los Angeles. All right? Then, of course, I went back with my iPhone the other day, and I took it again. All right? So there's been tremendous growth in California, especially Southern California. In 1950, there were only 10 million people in California. Now there's almost 40 million. So the population has quadrupled since the great droughts of the 1950s, all right? Since the great droughts of Jerry Brown's first term, all right? So all this growth increases demand in spite of what Mother Nature does. There's just more of us using more water, more power, more stuff. We're more affluent, all right? Good. There's more technology, all right? So in a semi-arid region like where we live, growth itself can create drought. Got that? All by itself. All right? So here's a formula. I love formulas, all right? So water and energy demands, which are W, equal population, but not just population. You have to multiply it by affluence. We're all living better than our parents. Not all of us, but in general. Everybody's living better, all right? Your parents didn't have 4 flat-screen TVs in the house, all right? You don't have a TV? Culturally deprived, yeah. Okay? Multiplied by technology, all right? And so every little smartphone out there takes a tremendous amount of water to manufacture. In 1950, there was no Silicon Valley. It was just agriculture. And so the result of all this is California is the 7th largest economy in the world. There's been so much growth and affluence, all right, of everything. The economy of California is bigger than the economy of Russia. It's bigger than the economy of France. It's the 7th largest all by itself. Right? And so here's a good example of what that causes. All right? So this is the volume in the Colorado River, the blue curve. You see it waxes and wanes. Goes up like that. And this is the 10-year average of the usage. There are 7 states and 5 Indian nations that take water out of the Colorado. Now, everybody, if you go to college, what happens when the supply curve, right, is lower than the demand curve. You're in trouble, right? And so that's where we are in many ways with water in the state of California, whether we're with a drought or without a drought, all right? The supply is smaller than the demand. That's just because there's more of us doing more stuff. It's success. So the demand is greater than the supply. Now, where do we use our water? This is a little thing. If you take on our left here is another formula. 100% of the available water. Now, 25% of it goes to the environment. What's that? Endangered species, all right? Maintaining marshlands, all right? It's legislated by the EPA, all right? Because you can't use all the water in all the rivers and kill all the creatures, all right? Just for the sake of almonds or lawns in LA, all right? You got to leave 25% in the rivers. And then 60% is used by agriculture. So 25 plus 60 is how much? So what does that leave you with? 15% is what is used for urban and industrial use. So that's sort of an inequitable distribution, right, of water supply. So for instance, Jerry Brown wants all of us to cut back how much? 25%. Now it's 25% of what number? 15. So what's 25% of 15? 3. Come on, what's 25% of 15? 4. All right? So what he's really asking for is 4% savings. That's an interesting idea, huh? So what's the 800-pound gorilla here? The 800-pound gorilla is the guys that are getting 60%. All right? It's agriculture. So now you're probably going to think I'm going to rag on the farmers, all right? But you're wrong, all right? So far in this drought, when their wells run dry up in the Central Valley and other places, all right, people that really work hard for a living, like ranchers and farmers, all right, let me tell you, those people work hard, all right? This is not like working for some tech firm, all right? This is hard work. A lot of them are fallowing their fields and they're going broke. So far in this drought, who's really felt the most pain are the farmers and the ranchers. Not necessarily all of them, all right? In the cities, we definitely haven't felt it yet. Because when I was coming down Pacific Avenue, I didn't see any brown lawns. And MacArthur, what is it? Is the Air Force Station there? I saw the biggest, greenest lawn I'd ever seen in my life. The only bigger one I saw was at Pepperdine University. Yeah? So there's not that much pain here in San Pedro. All right? So how much water does it take to do different things? So for instance, if you take San Francisco and Los Angeles and you put them together, that's about 1 billion cubic meters. All right? And then if you look at all the water that's produced just almonds all by themselves, it's almost 3.5 billion cubic meters. So they're using 4 times as much water to grow almonds in the Central Valley as all the users, urban users, in San Francisco and Los Angeles combined. Okay, you can just think about that one for a minute, whether that's right. And by the way, about 70% of those almonds are exported. All right. So let's talk about how we're going to get out of this. I'm not saying that's right or it's wrong. I'm just giving you numbers, all right? Let's talk about some long-term and short-term solutions. Now, does anybody know what the short-term solution is? What's the short-term solution? Use less water, all right? Yeah. We all have to use less water, all right? And it's not that big a deal, all right? Governor, you know I voted for him 4 times, I think I told you that. I love Jerry Brown, all right? He wants everybody to cut back 25%, all right? And this is a famous quote, another famous quote, all right? California urban residents standing on 1 foot with an arm tied behind their back, all right, can easily cut 25%, all right? No problem, all right? But then let's remember that when we cut 25%, it's only 3% of the total. All right, so the first place we can think of is where? Is our lawns, right? Because 60 to 70% of your water bill is in your yard. Say that 60 to 70% of your water bill is in your yard. And even in a drought, most people are over watering their yards 6 feet a year. There's no doubt everybody's over watering their yards. And you can always say, oh, it wasn't me, it was my Mexican gardener. You know, and that's nonsense, come on, you know. You definitely water in your yard too much. 1 or 2 days a week is plenty. A little brown is good, all right? And some people have. There are heroes out there. I know people, especially that lived through the 70 drought and the 87 to 92 drought. It became a habit with them in the older generation. And they're really good with water, all right? Whereas some of the young people aren't. And mostly rich people aren't, all right? So who are the worst abusers of water in their yards? Exactly. Beverly Hills, Rancho Santa Fe, all right? Palos Verdes, Pasadena, Sierra Madre, that's where I live, all right? All right? So, you know, what I would say is, you know, one of the things we have to think about in the long run, even after we get out of this drought, because there's so many of us, and there's so many different kinds of demands for water, there is a lot of water, all right? But is yards the best use of all that, all right? And so, you know, a lot of people are terminating the turf, you know. You know, and I like that, you know. It's time for Land's End. I always get the Land's. I thought of that because I get the Land's End thing on my iPhone all the time. I don't know how I got that. You know? And so that's something to think about. But of course, the big number, this is the easy number, is in your house. Inside your house, not outside your house. This is what you use in the house. 45% is in your toilet, and the other 30%. So between your toilets and your showers, it's 75% of your inside usage, all right? And then the laundry and the dishes, that's a no-brainer. Just don't do it with half loads. You know, never use your dishwasher and your washing machine, all right? And a front loader uses half as much water as a top loader, all right? The 5-minute shower is easy. Instead of leaving the water running when you're soaping yourself, just turn it off, all right? And as far as the toilet's concerned, all right? Now, I'm into it, all right? I'm definitely into it, yeah? It's not that big a deal, because every time you flush the toilet, it's 5 or 6 gallons, all right? The other way you can do it is throw a couple of bricks in your tank and make it a low-flow toilet. That's the cheap low-flow toilet. Just throw a couple of bricks in the tank. But think, every time you flush your toilet, that's 5 gallons, all right? So if you take a pee 5 or 6 times, you've saved 30 gallons of water. That's a lot, all right? And the average usage is about 160 gallons per day per person. So Jerry wants us to cut back to 40, all right? So by letting it mellow, you know, you've almost hit your 25%. It's that easy, all right? So how much water are different California cities using? I can barely see that. Can you see it? All right, the worst ones are on the top. Palm Springs, all right, Fresno, Bakersfield, and the champs are down here at the bottom. Santa Cruz, they don't have much water, all right? Monterey, Los Angeles is not bad. San Diego. But this can vary from everywhere from 600 gallons a day per person to places in Compton. And of course, poor people use less water. In Compton, they only use 50 gallons per day per person. All right, so they're asking them not to cut back as much as they're asking the people in San Pedro, taking those long showers, all right? All right, so the thing is very unequal, the distribution, all right? Rich people use more, poor people use less. So, in the longer term, all right, one of the things, I just made a sort of a list here. You have to confront what's the best use of water in the state of California. Where do you get the biggest punch for the buck? You know, is it agriculture? Is imported water better than local water? all right? Is water used for fracking gas and oil a good investment in the economy, all right? Now, some people say that the Endangered Species Act, and that 25% is too harsh. In a drought, they ought to back off a little bit and give the cities more water and the smelt less water. Something to talk about, all right? Then the other thing is that in Northern California and Sacramento, there are a lot of places that don't have water meters. Now, most of us have water meters. Some of us have smart meters. In Sacramento, they pay a fat rate. There are no meters, all right, for the farmers in the Central Valley along the Sacramento and the San Joaquin. So nobody really knows how much water is being used. It's kind of interesting. And then there's tiered pricing. You know, once you get above a certain level, they increase your bill. All right? And that works to a certain level, but it doesn't work because rich people don't care how much the water costs because they can afford it. And poor people get penalized in a tiered system. So that's got pros and cons, all right? Then there's wastewater. That's where when you flush your toilet, it goes into water treatment plant, it gets treated, and it gets recycled back into your kitchen, all right? Now they're doing that in Orange County. So I've actually been to the plant where the toilet waste comes into one end of the plant, and then they give you a cup and ask you to drink the water at the other end, all right? And look how good I look, yeah? So, you know, that definitely works. Recycling water. Why not reuse it, yeah? Then there's desalinization. I'll talk about that in a minute, all right? Then the thing I'm really concerned about is all these deep aquifers that we've been so dependent on. What happens when we suck them dry? Because that's really the last resort of reserve, all right? And then the other thing is water storage, is that we actually have a lot of water storage underneath Los Angeles. A lot of water basins where we can store water, but a lot of them are polluted. For instance, in the South Bay, when the aerospace industry pulled up and moved out, all right? So, you know, we have to clean up those groundwater basins and use them for storage, all right? And just in general, we need a better accounting system for the water. How much water is there really, and who is really getting it? At this point, nobody really knows. Okay, I'm getting near the end here. So this is a little thing, is some people say the water is too cheap. It is cheap. We actually get really good water in LA, and it's cheap. You know why it's cheap? Because it's heavily subsidized both by the federal government and the state. All these great aqueducts and water transport systems. So we have some of the most heavily subsidized water in the United States. That's why it's so cheap. The water bill is so cheap, all right? And so, you know, maybe we should just increase the price of water. Then, you know, some people complain about, my buddy Jerry, they complain about his high-speed rail system. And they say, well, why don't we invest that money in desalinization? Okay, now that's a good, that's an idea. But I'll give you an example. Right now there's a desal plant in Carlsbad. They've been building for 10 years. They've got over $1 billion invested. It's been under construction for a long time. And it'll provide about 7% of San Diego County water needs, all right? Produces about 50 million gallons of water per day. And it's an enormous energy hog. Takes a lot of energy, all right? When it starts up, if it does, it'll be the largest desal plant in the Western Hemisphere. Now, the only problem is when you desal water at the coast, what do you do with it? You pump it uphill, all right? So all of a sudden it gets even more expensive, all right? So that's one of the problems with desal. It's just the cost, all right? It's just flat the cost, all right? So I did a little calculation here. So if desal supplied 100% of California's urban water needs, all right, we'd need about 200 desal plants. That means we'd need one every 4 miles between here and Oregon. Okay. And so that is not a large-scale practical solution to the problem. Right? And of course, there's the aquifer thing, you know, which I talked about earlier, the infant aquifer myth, when we hear the sucking. Now, here's one that most people don't think about, is that California has a lot of water, but you know what else it has? It has a lot of oil and it has a lot of gas. You got to remember, one of the biggest oil strikes in the United States happened right around here, all right, in Los Angeles. And they're still pumping oil in Long Beach, in San Pedro, and Santa Barbara. There's a lot of oil being pumped around here. Not only that, there's a lot of oil in the city being fracked. Most people don't know that. So there is fracking, all right? And the problem with fracking is that it uses a lot of water and it creates a lot of wastewater, all right? And it's not trivial. Fracking equals water. So this is another calculation. In 2014, 4 trillion gallons of water were used in 25,000 fracking wells in California. Now, California, the South San Joaquin Valley, and the whole LA Basin has an oil shale that's one of the richest oil shales in the United States. You know, you read about the fracking in Oklahoma and Pennsylvania. You're sitting right now above one of the richest oil shale deposits in the United States. Right? Potentially billions of dollars. So all I can say is watch out for the Koch brothers, all right? Because, you know, that could really play havoc on your drinking water. Big problem. Yeah. So this is another fact. I love facts. Inglewood, for instance, is the largest urban active oil field in the United States. They keep it undercover. You wouldn't even know that, you know. We all see them, you know. All right. And then there's a lot of different ideas. You know, my whole career, people are saying, you know, why build an oil pipeline? Let's build a water pipeline from Canada or the Columbia River. Well, you know, I don't totally poo-poo that, you know. William Shatner the other day suggested it. It's not totally out of the question if it gets serious enough, because the largest water deposits in the Western Hemisphere are in Canada. And so potentially, we could turn the whole American Southwest, as well as northern Mexico, into a great big farm if we could build water pipelines from Canada. All right? I'm almost there. So in long term, the problem is, right now, 70% of our water is imported from the Colorado or Northern California. So are we too dependent on imported water? And in some ways we are. Because as we can see from this drought, it's short term. Because right now they're cutting off our water from the Colorado or from the Bay Delta because there's no snowpack. All right? So one of the real solutions is to clean up all the groundwater basins in Southern California so that we can use them for water storage. And that could potentially, if we clean them all up and fill them full of water during the wet years, could sustain us for 4 or 5 years. All right? And this is it. Here's the bottom line. The bottom line in all this, if you think we have a problem in the way we manage our water in the state of California, and we do, it's, you know, the water laws date back to the late 19th, early 20th century in terms of how we manage water and who gets the water. Pretty archaic, all right? So, in the end, this is America. How do you solve problems in America? You solve it at the ballot box, all right? So you vote for good people, they pass good legislation, all right? And then they enforce it, and, you know, you solve the problem. So in the long run, you have to be informed about water and water issues, and you got to make sure to get out and vote for people that think the same way that you do about water, because it's pretty damn important. And that's it. I told you more than I know. Thanks. Bill, thank you very much for a great talk. How about another applause for Bill?
can take a few questions right now, if that's okay.
Sure. Well, somebody always asks me that, and what's the period? How long does the PDO, or the Pacific Decadal Oscillation, last? And my answer is anywhere between 5 years and 100 years. Remember the megadroughts, right? And so it's not a nice regular thing like the tides, right? It's messy. Yes, ma'am. We have water basins all over Southern California where we store water, but a lot of them over the years have become polluted. And that could have been industrial, could have been military, some of it is agriculture. So I'll give you an example. In Pasadena, we have 16 wells, 8 of them are polluted. So you can't use the water out of those wells. And so over many years, we could clean out those basins by pumping them and cleaning them, and then they would be available for storage in the future. All right? And so what we did was we abused our basins. It's called basin abuse. So essentially you're asking, why don't we capture more rainwater? Okay. Well, first of all, there's not that much rain here, but that's not the real reason. In 1938, we had a big flood, a big El Nino. And what happened was that south of downtown LA, or in Orange County, where Irvine is today, in many areas, these are great big floodplains. All right? And so they had a huge flood, massive, I think it was 12 inches in 3-day rainfall. So for 2 inches on both sides of the LA River, everything south of downtown LA flooded. So they made a decision to not capture water, but go for flood control. So the LA River is concreted from the San Fernando Valley all the way to the port of LA. 51 miles of concreted river. And it's fed by 1,600 miles of storm sewers. All right? So the idea is when it rains, to get as much water out of the basin as quickly as possible. And let me tell you, the LA River is an engineering marvel. Whoever designed it, it's amazing how well it works. Okay, now what happened is that on both sides of the river, it's all built up. So the question is, let's beautify the LA River, all right? But there's actually been so much more construction and more storm sewers that in some ways, I calculated that one, I wrote a paper on that last year. It turns out that the LA River, as concreted as it is, it's marginal if we get a huge storm. So it could theoretically actually overflow as it is. So, I mean, that's the decision we made. And the reason we made that was in 1941, the Colorado Aqueduct opened up. And so everybody thought that would supply enough water to Los Angeles, in Orange County and San Diego County and the San Gabriel Valley. And so basically we don't catch that much water. There are catchment basins. On the San Gabriel and the Santa Ana River, it's better than the LA River. So when you go from the 210 to the 57 south, you notice all those big gravel pits? They're catching water there from the San Gabriel Valley, and it's going into an aquifer or a groundwater basin. So we do some, but the LA River is a classic. It's not the, you know, it's literally concreted for 51 miles. Amazing. Yeah. Okay, so he's asking, why don't we talk about meat and dairy industries because they're so water, and what you mean is because they're so water intensive. Or in other words, if we all became vegetarians, you know, that would save one hell of a lot of water. And all I can say about that is you're right, all right? But good luck. But in a way, we all have, in a way. I can't remember the last time I had a steak, you know? So it's, you know, I'm semi-vegetarian, and I just feel better, all right? Every time I have a steak right now, you know, it kind of puts me out. But if you think almonds are water intensive, try beef and dairy, as well as chickens, by the way, all right? And so things are not that bad yet, yeah? So you want to put McDonald's and Chick-fil-A out of business, right? Okay. Well, I think fracking has been shown to have a pretty strong impact when you massively frack in active fault zones. You can see that in Oklahoma and the Midwest, Pennsylvania, and a lot of places. And so that's another serious side impact. And, you know, let's get right down to it. Everything I've been talking about here is noise level compared to what? The big one, all right? So we definitely don't want to nurture earthquakes in Southern California. Do anything that would, but they've pretty much shown to actually, the idea is that you frack and you actually lubricate the faults because you have to send water into the fracking zone. So I don't know, I'm not a big fracking person. How does the negative PDO essentially impact, how does it physically drive the atmosphere into the jet stream pattern I showed you earlier, right? Okay, now what happens is that the eastern and central Pacific get cooler and warm water piles up in the western Pacific. And so there's a great pool of warm water that essentially transports heat out of the tropics, north and south, out of the mid-latitudes. So over the year, the tropics tend to gain more heat and the polar regions lose more heat. And so the role of the ocean in the atmosphere is to take that heat that accumulates in the tropics and transfer it farther north, all right? So it's a great heat transporting machine. Now, when you get all that warm water in the western Pacific, it drives something called the Hadley circulation, which is north-south, and it excites the jet stream in the pattern that I showed you. Now, during an El Nino or during the positive PDO, it does something very different because the Hadley circulation gets excited in the central and eastern Pacific. And so you see a totally different jet stream pattern, which tends to make us wet. That's the simple explanation. So you want to change microclimates in different parts of the planet? It's like a geoengineering experiment, yeah. You know, the small-scale geoengineering affecting the large scale, I doubt that would have much of an impact, okay, myself. It's like cloud seeding, yeah. It doesn't really work, yeah. It gives you water in one place where it would have fallen in another place, and so what you end up with is a lawsuit, you know. You seeded my clouds, right?
Bill, thank you so much for your time.